Folks, so in this section, as I said, we are going to be talking about operations with rational expressions. For all intents and purposes, you can think of that word rational as meaning fractional. And ultimately, rational expressions are just big, giant fractions. So, really quickly, what's an easier operation to do with fractions? Multiplying or adding? Your first guess might be adding. You know, adding's easy. But does anybody remember what we have to have with fractions when we add them together? Common denominator. So we're actually going to do multiplying and dividing first because multiplying and dividing are actually a bit easier. So multiplying and dividing is where we will start today. Tomorrow we'll get into adding and subtracting. So the first thing that we're going to do is look through some of these steps. Step 1 says to factor all numerators and denominators if possible. And for factoring, don't forget the very first thing we check for when we're factoring, which is GCF. So always, always, always check for a GCF first. So we factor all the numerators and all the denominators if possible. I actually would probably switch step 1 and 2 and do step 2 first because I think it's helpful with all of the different types of operations we're going to be doing in this unit to identify your operation first. So if you see that the operation is division, you are going to flip the second fraction and change to multiplication. You may remember this middle school phrase of keep, change, anyone? Flip. So we don't actually divide fractions. We keep the first one, change the sign to multiplication, and we flip or reciprocalize the second fraction. So keep, change, flip means we multiply by the reciprocal. Woo! So keep, change, flip, we factor all of the things, and then we cross off as many things as possible. So there's going to be some similarities to some of the mad spam stuff that we did in the last unit with taking out GCFs on the top and the bottom, but I think these problems are actually kind of fun once you get done with the factoring because it's done a lot of slashing and canceling common factors out. So if I have x minus 8 over x minus 8, can I cancel out the x's and then cancel out the 8's? It may seem a little fussy, but we actually don't cross off those individual parts. X minus 8 is an entire binomial factor, so when I cross things off, I don't get to cross off these individual parts, but I get to do that whole factor with that whole factor. So if I had x plus 8 over x, can I cross off that x with that x plus 8? No, because x plus 8 is an entire factor with addition in it. I cannot take out a part from that. So folks, you may want to add that you should trap any binomials or trinomials in parentheses so that you aren't tempted to take out pieces. So doing this, that's a big angry no. Don't do it. So we can only take out an entire factor with another factor. So we cancel common factors out. Cancel factors. So step 4 is to multiply to combine the remaining factors into one fraction. And that's kind of our big goal with these operations we're going to be doing is we want to take these big nasty expressions and instead of having multiple fractions, we want to get it down to one fraction, reducing fractions again if necessary. So looking at that first problem. Looking at that first fraction, what's our operation between those two rational fractions? Multiplication. So there's no keep, change, flip business. Instead, we can go straight to factoring these. Well, maybe before we move into the actual factoring, let's go ahead and trap that trinomial in parentheses, and that trinomial, and that binomial, and that other trinomial. That way I'm not tempted to take out, for example, that x squared with that x squared. I cannot take those out with each other because those aren't the same factors. I would have to have x minus 8 with another x minus 8. So right now, I don't have anything in common that I can factor. Let's go ahead and slide these fractions together. Multiplying on the top, multiplying on the bottom. And can I factor x squared minus 6x minus 16? We sure can. We're looking for a product of negative 16 and a sum of negative 6. What are my two numbers? We're going to have 2 and 8, and which one needs to be negative? The 8. So negative 8 times 2 is negative 16, and negative 8 plus 2 is the negative 6 that we want. So I factored that first expression, and then I have this x minus 8. And these are all joined by multiplication. So yeah, I have that dot that I brought down, but there's a dot here as well. Now that numerator is completely in factored form. Now looking at the denominator, we have x squared minus 16x plus 64. Anything jumping out at you about 64? It's a perfect square. And that just pushes me to try 8 and 8 as possible factors first. Does positive 8 and positive 8 work? It's close. Since our sum is negative 16, we'll have to have negative 8 and negative 8. That gives me positive 64 for the product and negative 16 for the sum. Now what about this last one? Product of 6 and a sum of 5. This one a lot of times will throw students off. They actually put it on the ACT a decent amount of times because students want to say that it's this. Why doesn't this factorization work right there? The 6 would be negative, so that doesn't work. So what are two other factors of 6? 2 and 3. So x plus 2 and x plus 3 would be my correct factorization. So now the fun part. Is there anything that we can cross off? Yeah. X minus 8 divided by x minus 8 is 1. So just like 2 over 2 is 1, 3x over 3x is 1. I can cancel these out because they are equal to 1. What else can I cross off? X plus 2. With that x plus 2 on the bottom. Now, could I have crossed off the x minus 8 with that x minus 8 on the top? No, we're only crossing off tops with bottoms because that's what gives me 1 in the fraction and simplifies it. But we can take that x minus 8 out with that other x minus 8. So then, what are we left with? The x plus 3, and where are we left with x plus 3? On the bottom, so it's got to stay in the denominator. So 1 over x plus 3. And I like to continue to trap those binomials in parentheses just so you're not tempted to take out pieces from them. Congratulations. That is your first simplifying rational fractional problem down. Let's go ahead and take a look at the next problem. I'm going to go ahead and trap the binomials, trap the trinomials. Things that are separated by addition and subtraction are all one thing in the fraction. Next, I identify my operation. These ones are joined by division. So as soon as I see division, I think keep, change, flip. I'm going to keep the first fraction. I'm going to change that change that division to multiplication. And then I am going to flip or reciprocalize the fraction. So the x squared minus 12x plus 32 is going to go on the bottom, and y squared minus 3y minus 18 on the top. So keep the first fraction, change the division to multiplication, and flip the second fraction. And I'm going to completely cross this off so that I'm not tempted to do that old part. We have completely changed the problem to be multiplying by the reciprocal because that is how we divide fractions. Next, we want to try to factor. Can I factor x squared minus 16? Yeah, difference of squares from the last unit. We're pros at this. So x squared is a perfect square. 16 is a perfect square. So I can factor this as x plus 4 and x minus 4. Then we join that together with my other fraction part. And can I factor y squared minus 3y minus 18? We want a product of negative 18 and a sum of 3, negative 3. If you struggle with finding the pair that works, remember, you can use your calculator to help you. I can divide 18 by 1, so 1 and 18, that's not going to give me 3. I can divide 18 by 2, 2 and 9, that's not going to give me the 3. Can I divide 18 by 3? Yep, and 18 divided by 3 gives me 6, and that combo will work as long as who's negative?
6.
The 6, so y minus 6 and y plus 3. Woo! Now on the bottom, can I factor 12y plus 36? Our first instinct is no, Ms. Scarrow, it's not a quadratic, it's not a polynomial. Why would we even try to factor something like that? Folks, normally we leave stuff like that alone, but for simplifying, we need to make sure that we factor fully. What's the first thing we check for when we're factoring?
GCF.
A GCF. And do we have one in that weird little binomial?
Yeah,
we do. So we can take a 12 out, which leaves me with y plus 3. So folks, in big letters by this, GCF. Students tend to not miss them when they're coming out of a quadratic, but these weird little just binomial expressions that don't make us think factoring are quite easy to miss. So as you are checking on the answer key on the homework, if you're like, wow, I got a lot more factors or a lot more things being multiplied together, chances are you didn't factor something fully, and that's why you don't have as much simplifying going on. So we can take out a GCF on that one. Moving on to our next denominator. Product of 32, sum of negative 12. 32 divided by 1, 32 and 1. 32 divided by 2, 2 and 16. 32 divided by 3, that's gross. 32 divided by 4, 4 and 8. What combo will give me 12?
Negative 4, negative 8.
Perfect, so negative 4 and negative 8.
Michaela McFadden and George Cooper, please come to the attendance office.
So now everything is factored, so the fun part, I gotta start crossing things off. So I can take out what here, folks?
X minus 4.
X minus 4, X minus 4. What else? Y plus 3, Y plus 3. Is there anything else we can take out? Can I take out an X from this and an X from that? No, they're trapped inside parentheses. Unless it's an X plus 4 on the bottom, I cannot take out any parts of the factor. So what are we left with? We're left with X plus 4 and Y minus 6. And then 12 and X minus 8. So on the top, if you're like, are we going to have to FOIL that stuff together? Short answer is no. Leaving it in factored form is considered the most simplified version. So we're going to leave it as X plus 4 and Y minus 6 on the top. And then on the bottom, even the 12, which wouldn't be that horrible to distribute, we leave that factored out in front. Monomials tend to go out in front for proper form. We leave it out in front and we don't distribute it. And that's our final answer for that one. Any big questions so far? Or little questions? Yes.
Will we have to put the multiplication sign between the x plus 4 and x minus 6 because they're separated by
Nope. So you can just write those parentheses next to each other. It's implied multiplication. So if you're wondering why have I been doing it up here, it's when we slide those together that multiplication carries up to the top and the bottom. So you don't have to show that. It's just kind of showing that that's what's happening when we're joining those fractions together. Good question. All right, folks, moving on down to this problem. We first trap that binomial. Trap that trinomial. Trap that other trinomial. But what about 15y squared? It's a little bit strange because we don't normally think of it this way. But if I told you to factor 15y squared, could we break it down into 3 times 5 times y times y? You're like, yeah, I guess, but why would we do that? Monomials have very fragmented factors. I wouldn't want to do that to the 24y or to the 3y squared because this is a binomial expression that I want to break up into something times something else. But for monomials, it's all multiplication within the expression, which is why we're going to kind of mince it up in order to be able to cross off and simplify. So more on that in a moment. First, our operation. It is multiplication, so that means factor and go. What can I do to factor 3y squared minus 24y?
Divided by 3y.
So wonderful, we got a GCF. So I'm going to take a 3y out of both of those. And that will leave me with y minus 8. Then we join these fractions together. And product of negative 24, sum of 2. 1 and 24, 2 and 12, 3 and 8, 4 and 6. 4 and 6 is going to do it for us. Who needs to be negative? 4, so y minus 4 and y plus 6. This will give me a positive 2 for the sum and a negative 24 for the product. Then we move to the bottom. So we've got 15y squared, which we've said, yeah, or we could expand it out if we wanted to. And then we've got y squared minus 12y plus 32. Hey, that's that y minus 4 and y minus 8 again. So now the fun part, what do we get to cross off? Y minus 4 with y minus 4. And when we cross those off, it's because it equals 1. Y minus 4 divided by y minus 4 is 1. Y minus 8 divided by y minus 8 is 1. Now, what about this? I said up here that I can't take out parts from binomials with each other. But what I can do is if I have x squared over x, I can take out an x from both of those. This is exactly what we did in the last unit with those math spam rules. I am allowed to do that because x squared is x times x. Those monomials are easy to think of in factored form. So folks, if I wanted to, I could break this up into 3 times y and 3 times 5 times y. And if that helps, you make it a little bit more obvious that we can take out a 3 with that 3, a y with that y, which would leave me with a 5 and a y on the bottom. Or if you're okay with what we did in the last unit, if I look at 3y over 15y squared, we can take a 3 out of both of those, which also leaves me with a 5, and a y out of both of those, which leaves me with a y on the bottom. So if you want to do the factor tree expansion, you can, or just note that you can take GCF pairs out of the top and the bottom when you are dealing with monomials. The little phrase that I used to use when I taught Algebra 2 is mince monomials. What does that word mince mean? Any culinary students in here? What does mince mean? you like chop it up really finely. So monomials, we can kind of hash it up and mince out the individual pieces, versus binomials, it has to be the whole thing. So what we are left with in this problem is the y plus 6 on the top and the 5y on the bottom. So y plus 6, trap, over 5y. Let's go ahead and look at the next one. First, is there anything for me to trap in parentheses? Not really. These are all monomials. So this is all joined by multiplication. That is all joined by multiplication. So the x, the y cubed, those are all already factored because monomials are all joined by multiplication. So next we move to our operation. This is division. So we're going to keep the first fraction, change the division to multiplication, and flip the fraction. So 35a squared b on the top, 12x squared y on the bottom. Goodbye dividing, hello multiplying by the reciprocal. So let's go ahead and write these as one fraction. I've got 18 times x times y cubed over 7 times a squared times b squared times 35 times a squared times b times 12 squared y. So I wrote all those dots in there to show this is all multiplication. So this is factored form for the top. And yeah, we could break it down more. I could break down the 35 into 7 and 5, the 12 into 3 and 2 and 2. But let's just see if we can use our old rules from the last unit to simplify. I would start with your numbers first. Is there anything I can divide out of 18 and 7? Nope. What about 18 and 12? Yep, we can take a 6 out of both of those, which will leave me with a 3 on the top and a 2 on the bottom. What about my 35? Is there anything I can divide out of 35 and 7? A 7, which leaves me with a 5 on the top and a 1 on the bottom. What about any other of my top-bottom pairs? Can I take out any more items? So now I would move alphabetically to your variables. I look at my a's. Anything I can cross simplify? Yep. A squared over a squared is 1. Goodbye. How about the b's? Take out a b from both of those and we'll be left with a b on the bottom. Next to my x's, I can take an x out of both of those, which will leave me with a x on the bottom. And then a y out of both of these, which leaves me with y squared on the top. These problems can get kind of messy. If you want to use different colors to write what you have left, it still can be easy to miss things. So find a method that works for you. I like to write what's left above, but you could also just write it on the new line of work. It's totally up to you. But now we want to write our final answer. Since these are all joined by multiplication, how do you think we should write the numerator? We're going to multiply 3 and 5 to get 15, and then the y squared. So since those are monomials, we're just kind of mushing them together into one fraction, one term. Then on the bottom, we have 1 times 2, which is 2, and then bx. Could I have xb? Yep, xb is the same as bx. However, if you want to make checking on the answer key easier, it is considered proper form to alphabetize your variables. It's the same answer. I do not care what order you have them in, but proper form states alphabetically with your monomials out in front. So folks, that concludes page 1 of the notes.